Welcome to the tutorial series of Multiscale.Sim. The demonstration is about nonlinear version tutorial, which is elasto-plastic homogenization analysis. This tutorial can be found in Multiscale.Sim document, nonlinear version Workbench tutorial. So, before starting the demonstration, let me give you the overview of analysis. In this tutorial, we will use a carbon fiber reinforced plastic material that is unidirectionally reinforced as an example, and then we will perform the numerical material testing. Since this is the nonlinear version, we have to identify the anisotropic elasto-plastic material constant by cup fitting. Then we will get the apparent material response in each direction of numerical material test as a result. So as you can see here, this is our analysis model, unidirectional composite material. Fiber material is carbon fiber, and matrix is nylon 6. You can also see the material properties of the nylon 6 graph here, the plastic strain and the stress graph. Also, the carbon fiber EM modulus and Poisson ratio are provided here. As a special note, you need Multiscale.Sim nonlinear version license to perform this tutorial. And also you need to have the Mechanical Enterprise. You can also perform this tutorial by Mechanical Premium license, but however, the material model that can be used in Mechanical Premium is isotropic bilinear approximation only. So let's start to perform the analysis. Multiscale.Sim can be opened by Multiscale.Sim Launcher application. You can find Multiscale.Sim Launcher as can be seen here. Right-click, select Run as Administrator. Click Yes. Select the version, select the license, and select the environment you would like to use. Here I will select Workbench, then click Run. Now, Multiscale.Sim can be seen here, and it can be successfully opened in the NC Workbench environment. So from now, we will create new analysis system. Click on the static structure and drag it on here. Then let's assign engineering data. Double-click on the engineering data, then click on the engineering data source. From the data source, let's find Multiscale and select carbon fiber and nylon 6 elasto-plastic here. Okay, close the engineering data. Now we will create unidirectional composite by using SpaceClaim. Geometry templates are provided on SpaceClaim and also in the design modeler, but in this tutorial, I will use a SpaceClaim to create the model. So to create the unidirectional model by SpaceClaim, click on the geometry, right-click, click on the Multiscale.Sim geometry, and here you can find the provided geometry templates of the Multiscale.Sim. So select unidirectional. Then double-click on this unidirectional. After waiting for a few seconds, SpaceClaim is open. Here is the input parameter. Click on the unidirectional and the script. Right-click, select Edit Script. You can find the script information here. So our model input is fiber fraction is the 50%, filament fraction percent is the 100, and fiber length is set as 0.1 milli. To create the model, click on the unidirectional, left-click, and click on Run Script. As you can see here, the script is running and model is created successfully. You can check the fiber diameter information here. Let me explain about how fiber diameter is determined. When the fiber diameter is set as 0, unit cell transfer duration is fixed as 1 unit length. You can see here overall length is 1 milli. Diameter is calculated based on the fiber fraction percent value, which is 50 as we import here. Therefore, the actual fiber diameter value may differ from micromodel, but if the fiber fraction percent between actual model and micromodel is same, difference in diameter value has no problem. This is because homogenization method is based on law of similarity similitude. Let's also confirm the created micromodel dimension. We set the fiber length is 0.1 milli. So if we measure the micromodel length, we can confirm that the model is currently created with 0.1 milli fiber length. Okay, now close the SpaceClaim. After creating the micromodel geometry, double-click on the model. First, we will do material assignments. So click on the geometry. From unit to right, select Matrix. In Details view, Assignment, click on the arrow here and select Nylon 6 elasto-plastic. Then select all the fiber by Shift-click. From Material Assignment, click on the arrow again, select Carbon fiber. Now Material Assignment is finished. Let's move to Mesh. Click on the Mesh. From Mesh on Toolbar, select Sizing. In Geometry Selection, click on it. Then select Body. Select all the body except for the middle one. Click Apply. Set element size as 3.3 10⁻⁻². Then select Sizing again. This time we will select the remaining body. Click Apply. In element size, define element size as 7.5 10⁻⁻². Then click on the mesh again. Right-click, perform Generate Mesh. Okay, now meshing is complete. From now, we will perform numerical material testing. Click on the Multiscale.Sim. In this tutorial, we will create a numerical material testing system. Therefore, click on the numerical material testing. Click on the parameter identify set. As you can see here, the dialog appears. You can select the different kind of the material testing. In this tutorial, we will perform elasto-plasticity. So click on the elasto-plasticity. Then click on the Create System. After creating a system, the dialog box is appear here. Click on OK. So let's define nominal strength value that you would like to use. So here we will set 0.02 as nominal strength value. Number of steps is defined as 25. Then click OK. As you can see here, the first one appear here is for linear homogenization. And then the other are the material testing for XX, YY, ZZ, XY, YZ, and AC direction. Total of the 6 direction systems are created here. Since the amount of strain applied for the material testing is large, and also this tutorial is for nonlinear elasto-plastic problem, we need to enable latch deflection for the analysis. To do that, except for the linear homogenization, select all the analysis setting of material testing. You can do that by Control-click. Here's in the Details view, you can find Latch Deflection set as On. Okay, then to run all 7 analysis systems, click on the model, click on the Home, and then click on Solve. Now analysis is complete. You can confirm analysis is complete by seeing the green check mark appear in each analysis system. As you can see here, there is a green check mark in all analysis systems. Let's check result of the linear homogenization first. So click on the MSK homogenization under the solution tab. If you click on it, you can see the window appear here. You can check the EM modulus, shear modulus, Poisson ratio, density, and elastic matrix property of the composite. As you can see here, the EM modulus in X, Y, and Z direction. The X direction is largest because the fibers are oriented in the X direction. Okay, I will close the window. Then let's confirm the material response of nonlinear numerical material testing. Make sure to select the solution and the material testing tension XX. Then select the Multiscale.Sim from toolbar. From Numerical Material Testing tab, click on Macro Response Result. After selecting the macro response result, you can see that the macro response result appear under the Solution tab. And you can also see the graph appear here, which is the material response stress strain cutoff numerical material test. As you can see here, triangular blue is the numerical material response in X direction. In X direction, fiber is behave as an elastic body, and load is mainly carried by fiber. That is why it is behave linearly. In the other word, the straight line. Then click on the solution under material testing tension YY. Select numerical material testing, click on macro response result again. There you can see material response of numerical material testing in YY direction. Material response in YY direction is nonlinear. This is because the load is applied in the Y direction. The applied load is mainly carried by the matrix. That's why you can see the nonlinear behavior in this case. You can also check the other direction material response result by click on the solution. Then from the numerical material test, click on the macro response result. Repeat the procedure. Okay. Now you can confirm all the macro response results. For nonlinear elasto-plastic material model, to know the Haley criterion, we need to perform curve fitting. Click on the solution and the material testing tension A6. Then, from the toolbar, select Multiscale.Sim. From nonlinear, select homogenization setting. Now you can see nonlinear homogenization setting appear under the solution tab of tension A6. From details view, you can confirm material type is elasto-plastic and stress strain property type is multilinear. Then click on the nonlinear homogenization setting. Right-click, click on Generate. When the process is stopped, you can check the overall progress in the left bottom of the window, and also the Multiscale.Sim progress. This window is appear. Please wait for a while to finish the process. After the curve fitting process is finished, you can see the green check mark appear beside the nonlinear homogenization setting. Then again, from Multiscale.Sim toolbar, from nonlinear, select curve fitting result. Now you can see the nonlinear homogenization chart is appear under nonlinear homogenization setting. As you can see, this blue triangle is numerical material test result in X direction. Solid blue line represent curve fitting result in X direction. You can see that the curve fitting result show good agreement with the numerical material testing. To check the curve fitting result of other direction, to do that, first we will remove the displays of X direction result. From the details view, from the chart setting, we will remove display of plot 1 and plot 7. So select on the plot 1. From the drop-down list, select None. From plot 7, from the drop-down list, select None. Okay, now we can clearly see the other directions curve fitting result. You can see the good agreement between curve fitting result and numerical material test result. You can also check the value from the tabular data window. If your GUI doesn't show tabular data window, from the solution tab, you can click on the tabular data. And also you can check the data by the CSV file type. To do that, select on the solution, right-click, select Open Solver File Directory. Now you can see the card fitting folder. To check the card fitting result, double-click on the card fitting folder and you can see the fitting res.csv. The data are summarized in file. And also for the macro response result, you can also check here, string.csv file. Numerical material testing results are summarized in CSV file. As a last step, we will export the material property to the material library. To do that, select on the Nonlinear homogenization setting. From the detail, from the engineering data, please define material name. Here we will define CFR EUD 50%. Then click on the Export. Click Apply. Now you can see done in the export, which means the material data are exported successfully to engineering data. So let's check the engineering data. Go back to the Workbench window, double-click on the engineering data. From engineering data source, select Multiscale. CFRB-UD 50% can be found in engineering data. The details are here. Air modulus, Poisson ratio, shear modulus, and Haley criterion are as shown here. So this is the end of the tutorial video. Thank you for watching our video tutorial series.